guys, so this would be our start to chapter 3, and within this chapter we'll be going over exponents, which we'll be doing today, exponential equations, then going to logarithms, and then logarithmic equations as well. Alright, so for this first lesson, we'll be going over a lot of general exponent rules, aka the basics. So a lot of these you've seen before, which is great, but you know, it's good to kind of refresh what we've kind of learned before as well. Now for these 4 scenarios, I'll provide examples as well. Again, a lot of these you know already. Let's start with this first one. A to the 0 power is equal to 1. Well, makes sense. Anything to take into the 0 power is always 1. So just for a quick example, let's say 5 to the 0 power, that is going to be 1. No matter if it's a number or a variable, anything to the 0 power is always 1. This next example, we have a to the negative p. What we notice here is we have a negative exponent. When we have a negative exponent, we don't like to deal with negative exponents, so we want to change that. What you do here is you want to change it, if it's on the numerator, you want to change it to the denominator, and vice versa. So again, let's say we have 6 to the negative 2. Well, again, negative exponent, we don't like to deal with those. We're going to have 1 over 6 over 2. Next example, we have a to the 1 over p power, this being our exponent. And we can kind of divide this up into, well, top part is our power, bottom part is our root. Now, with any exponent, we can always put it into radical form, which we've done here. Our root being part of our index, and base goes inside our radical, and this is being taken to the power of 1, which you'll kind of see a better example on the bottom. But that's how you want to put your, you know, how you want to set that up. And again, let's show a quick example. Let's say 5 to the 1 over 3 power, right? So how I want to set this up is, well, 3 is my root, serves as my index for this radical. 5 is my base, and again, it's being taken to the 1 for the first power, which you'll kind of see where that power goes right here. So again, this and this are really the same thing. They're saying this basically the same thing, just kind of different scenarios. Again, this is our power, this is our root. So again, any exponent can be written as a radical. So let's say we have an example of 7 to the 3 over 4th power. Okay, so again, power, root. So 4, square root of 4, or sorry, 4th power of 7, and this is being taken to the 3rd power. Alright, what I'm about to go over next is kind of going to divide this up just like how the book has divided this up. When it comes to exponents, there's rules that apply to same bases, and there's the rules that apply to having the same index. Now, before I kind of differentiate between the two, I do want to clarify what is a base, well, and what is an index. So for example, let's say we have x to the 5th power. Our x would be our base, and our 5, that exponent, would be our, it's another way of saying exponent, would be our index. You can say obviously exponent, or you can say power. All 3 of those mean the same thing. So that's what I mean by index and base. Alright, so some rules that apply to same bases. Now, when we're multiplying the same base with exponents, we want to add those exponents. And again, I'm going to show you quick examples just to kind of, so it's not so abstract. Let's say we have 9 to the 1/3 power times it's 9 to the 1 over 6 power. We've got the same base. We might have different exponents, but we have the same base. We can just add those exponents together. So this would be 9 to the 1/3 plus 1 over 6. Different fractions, that's no problem. Multiply this by 2, so this is 2 over 6. And we end up with 9 1/2. And you can actually go a bit further. So this, again, apply the rule that we just learned. This is be our power, this is be our root. So this is be a square root of 9, which is 3. Alright, so when we have the same base, and we're dividing our exponents, we want to subtract our exponents. So, and again, quick example. Let's say we have 4 to the 3 over 4 power over 4 over 9 divided by 4. Again, same basis, we can subtract those exponents. So what we're going to have is 9 over 4 minus 3 over 4. What we end up with is 4 over, and we can simplify here, 6 over 4, which is just 3 over 2. Okay, and we can keep on going further, because what can we do to this? Well, power and root. So this would be a square root of 4 taken to the power of 3. So 2 square root of 4 is 2, taken to the power of 3 is going to be 8. Alright, so some same index rules. And again, index referring to its exponent. Now, first example, we're multiplying. Yeah, we don't have the same base, but we do have the same index as mentioned. So what we can do is multiply the bases, a times b, and take it to the power that they were both being taken to. Example of this, let's say we have 8 to the 1/2 power times 2 to the 1/2 power. Again, same index, which is great. What I can do is 8 times 2 and take it to the same power, 1/2. 8 times 2 is 16. 16 to the 1/2 power. Well, again, you know that rule now. This is my power, this is my root. This would be a square root of 16, which is just 4. Alright, so next example. Again, different bases, but we do have the same index, so we can take advantage of that. So for this example, let's say we have 12 to the 3rd power divided by 6 to the 3rd power. Again, same indexes, so we can simply say 12 over 6 to the 3rd power, which is 12 over 6 is 2. 2 to the 3rd power is 8. Alright, so this example really doesn't fall in with same base or same index rules. It's kind of on its own. This is power to a power. Again, you should be familiar with this already. Let's go through an example very quickly. Now let's say we have 3x squared, and this is the whole thing is being taken to the 3rd power. Now don't forget, you actually have two exponents here. This 3 is being taken to the 1st power. That x is being taken to the 2nd power. It's attached to both these, both the coefficient and the variable. So 1 times 3, so that's 3 to the 3rd power. This would be x to the 6th power. What we end up here is having 27 to the x, or x to the 6th power. Alright, so our example problem, we have if 3 to the power of x is equal to y, express 3 to the 4 minus x power in terms of y. Now, this might seem a bit complicated, understandably so, but it actually falls down to a concept that we kind of mentioned earlier, and that I actually know that you knew before coming into this video. Now, I just want to remind you, what I'm actually talking about is something we mentioned a bit earlier, which is this concept. Again, same bases, we just add the exponents, like so, which I know you guys know how to do. Now, we know it from left to right, but we can actually go from right to left and kind of break this down from here, our endpoint, to where we can actually divide this up into two terms. So if we can go, if we know a to the m plus n power, we can split m and n back into its original form. We have where we have a to the m times a to the n. So knowing this concept, we can kind of break this down like mentioned before. So what we can do is, well, we can say 3 to the 4th power times 3 to the negative x power. Now notice, we broke it down to two terms. Now we can kind of break this down even further. So 3 to the 4th power, it would be 81 times, well, we can kind of break this down into, let's say, 3 times x times -1. And what we have here is, well, let's look back on our problem. It said 3 to the x power is equal to y. Well, I see 3 to the x power. So we can say 3 to the x power is y times 81. And what we can do is, well, 81 times y to the -1. We've got a negative exponent. We need to flip that to the bottom. So what we have is 81 over y. Alright, so what we have here is something very familiar to us. I think you guys remember this. You guys struggled on this a bit in our pre-algebra days, but we've come a long way, so I think you guys are all, can do this a bit better. Now what we have here is we have radicals in the bottom, and that's a problem. We cannot have radicals in the bottom within a fraction. So we gotta get rid of those. We have to rationalize the denominator. Okay, so what we do here is essentially multiply by its opposite, or basically flip the sign. So we multiply with the same thing, except we just take the opposite sign. And what we do on the bottom, we also have to do up top. We're multiplying by the same exact thing. Okay, now what we're going to end up with is we're going to FOIL here. So just be careful in how you end up foiling, but let's go through this process just one term at a time. So we have for let's do our first part of our FOIL. That would be 8 square root of 3 times square root of 3. Well, that's just 9 or 3, isn't it? Outside, that would be 4 times 3 is 12. Square root of 3 times square root of 2, that would be square root of 6. Alright, let's go ahead and do the bottom now. Again, FOIL. Alright, okay, we need to simplify this a bit more.
Alright, let's go from left to right. So we'll do the top first. So 24, we've got 12 square root of 6 minus 6 square root of 6. They have the same radical, so in this case we can just do plus 6 square root of 6 minus 18. On the bottom we have 12, this and this cancel out, minus 18. Let's simplify this a bit more. 24 minus 18 is 6, plus 6 square root of 6 over 12 minus 18 is negative 6. Now again, you can kind of split this up, because this, we can do 6 divided by negative 6, that would be negative 1. 6 square root of 6 over negative 6, that would be
-1 square root of 6. That is your answer. Alright, so here are your two practice problems. I've given you two since these are pretty quick. Your first practice problem is if 2 to the power of x is equal to y, express 2 to the power of x plus 3 in terms of y. And then your practice problem 2 is to rationalize this problem. So go ahead and try those out, and we'll see you guys tomorrow.